Today you're working on graphs of exponential functions. So you have not done exponential functions before. So far you have been dealing with straight lines, all different type of straight lines. Those were linear functions. So this is something new, which is exponential functions. So exponential functions are not straight lines, they are curves. And there are two different type of curves. One, they show growth, and the other one that shows decay. So our job is to be able to graph the exponential function that model growth and decay and identify the key features such as y-intercept. So y-intercept is still the same thing. It's going to be on the y-axis when the graph is going to cross the y-axis. Asymptote. Asymptote is a new thing. Asymptote is a point, it's not a point, sorry. So asymptote is the axis where the graph likes to go, but it's never going to cross it. So we'll talk about that. So exponential functions, they are actually easy. It's more of understanding what is happening in the situation. So exponential functions are f of x equals a multiplied by b to the power of x. Now, why this is called exponential function? You have the keyword exponent in it. So that x basically is the exponent. This is the exponent. It's not written right next to it. It's in the power. This is the exponent. The other way of writing it, the one that you're familiar with, y equals a times b to the power of x. So y is the other name of f of x. Now, it has two different letters, a and b. What do they represent? So a is basically the y-intercept. So if you are able to see the graph, this is going to be the point that crosses the y-axis. This is also known as initial value, also known as starting point. So where the graph starts or where your situation starts, or starting, y-intercept, initial value, beginning. So these are some words that go with the y-intercept. B is the growth or decay factor. This is also a multiplier. This is also known as ratio because that multiplier can also be written as a fraction, like 0.5 is also 1/2. An exponential function. So that blanks fills the exponential. An exponential function is a non-linear function, so it is not straight line. They are curved. They are going to be like this. They could be going down. So this one is actually going up. So that's going to be growth, and this one is going down. That's going to be the decay or decrease. How do you figure out growth and decay? Well, if you see it, you get to see it. But if it's a graph, you have certain, that B tells you if it's going to be a growth or decay, and we'll talk about that next. The attributes, straightforward. The point where the graph crosses the y-axis. What do you think? What is that point? Y-intercept, which is given as a in the function. If you forget, the good thing about this one is you can put it in the Desmos calculator. You actually can see the y-intercept, and you will be able to tell the y-intercept. So see using Desmos graph. The constant common ratio, the multiplier, that is the B growth factor. This is how you find subsequent y value after the initial value. So subsequent y value means the next y value. So I can figure out the y values using the multiplier. If b is greater than 1, if that b value is greater than 1, it is increasing function. So increase needs to be going upward. You see the arrow? It's the trend line is going up. This is increase. So b greater than 1. This symbol means greater. When is it decreasing? It's decreasing, decay, when your b value is more than 0 but less than 1. So it is between 0 and 1. In easier words, between 0 and 1. It cannot be less than 0 because your growth factor can never be a negative number. That thing happens in real life, so it's never going to be a negative number. And it is not going to be above 1 because if it was greater than 1, that is going to be increasing. So it is between 0 and 1. So that b, by looking at it, I can totally tell whether it is going to be increasing or a decreasing graph. Again, you can graph it in the Desmos and you can see. The line that graph approaches and get closer to but never reaches or touches or crosses. So that is asymptote. Asymptote. I'm writing it separately so you are able to pronounce it. Asymptote. I also sometimes say it as asymptote just because that A sounds like asym. So asymptote or asymptote. This is a line that graph likes to go towards, but it is never going to cross. So this is always a horizontal line, which is that x-axis. So horizontal line and x-axis in your algebra 1 because you deal with normal exponential function. So your asymptote is going to be x-axis or the horizontal line. I have a table, I have a graph, I have an equation. I can read all of this and I can describe where the things are. If I match the equation, this is y equals ab to the power of x. Your y-intercept is 16. Y-intercept is where x is 0. This is your y-intercept. So y-intercept where x is 0. So your starting value, y-intercept, initial point is 16. And yep, you can see it in your graph as well. This is your y-intercept. As you can notice, it's on the y-axis. So what is the y-intercept? Y-intercept is 16. And I will write as an order pair 0, 16. Multiplier. Multiplier is that b value over here, which is 1/2. Or 0.5. It can also be written as 0.5. And I can see that or calculate that value from that y as well. 16, how does 16 went to an 8 when it was half? 8 to a 4, again half. 4 to an 8, again half. 2 to a 1, again half. So that was my multiplier. Now, is it growth or decay? Look at the graph. It's going down. So this has to be a decay. So if it's a decay, that has to be decreasing. And I already wrote the word down. So this is decreases or decreasing graph. So the function is decreasing. Decreasing. I can also tell that value from that b, because remember, if b is between 0 and 1, it is going to be a decay. So look at that multiplier. This is multiplier is b. Y-intercept is a. So if b value is 0.5, that is between 0 and 1, it is going to be a decreasing. And asymptote over here is the horizontal line, which is going to be the x-axis. according to this graph. So these are the key features that I can tell by looking at my equation, by looking at my graph, or if I have a table, I can tell by that as well. So this one was decreasing, so I'm not solving the next one. You can solve the next one on your own. This is also decreasing, so you can solve. I'm gonna help you with number 3. You can solve number 4, and then we'll move on to the domain and range. All right, so let's talk about number 3. I have a graph, g of x equals 6 parentheses 1.25 to the power of x. I am going to rewrite this as y equals 6 1.25 to the power of x, because this is what g of x means. And I'm also going to write my actual equation above it. This is a b to the power of x. So I know that this is exponential function because x is in the exponent. All right, so by looking at the equation, I can actually answer everything from here. And then okay, you know what? Let's first fill the table and the graph and then answer all of it. How do you get the y values? You can practically use the calculator and get the numbers. So y-intercept is where you have x as 0. So this is what the y-intercept is. So pay attention, it's not the first number, it has to be the x is 0. So y-intercept is 6. I'm gonna get next number. If I next number, the multiplier is 1.25. So y-intercept a is equals to 0.6. Multiplier b is equals to 1.25. Remember, this is greater than 1. Growth increases, we'll see the graph and then we'll answer those questions. So 6 multiplied by 1.5 is going to give me the next number, but that's 2, 4, 6. So I'm just going to use the calculator. And how you use the calculator, I'm going to plug in the value of x. So there's no space over here. Let me see, how can I write my steps? So I'm going to find the y when I'm going to plug in the x, which is 6, 1.25, and x I'm looking for is 2, so that goes in the power. And I'm going to use the calculator from here so that I can get my number. So I graphed it, I calculated it. It is equals to 9.375. So when x is 2, it is 9.375. I'm going to check the next one with the 4. 1.25 and then 4. Use the calculator, replace the value of 2 with a 4, and you will have the number. It is, wow, that's a very long number. 16.65. I'm going to round off 65. And then I'm going to find for 6. It's going to be 22.888. So I'm going to round off to 8.9. Same way, I'm going to find the other values. When it is -4, it is 2.46. And then when it's -8, it is 1.01. When it is -12, it is 0.41. So I practically just use the calculator. I'm replacing the x every time I'm getting my number. These are exponents, so I'm gonna recommend you to use a calculator so you don't mess up the numbers. So let's graph it. Starting point, this is your starting point. 0, when x is 0, y is 6. There you go, this is the starting point. X is 2, this is 9.375. Oh, that is 9 would be here, so it would be somewhere here. And then when it is 4, it is going to be 16.65, which is 1416, which is not here, so I'm going to assume it's kind of here. -4, it is 2.46, so round about 2.5. Here you go. And -8, it is going to be 0.4, so there, no, sorry, -8 is 1, so it's going to be here. And then a -12, it is going to be somewhere here. So I have my graph, and I'm gonna draw a dotted, well, it's going to be a solid line, but I'm gonna trace using this technique. And give it a curve. There you go. It's a curved line which is increasing. That means it is going to be a growth. So is it growth or decay? It's going to be a growth. And the reason is also b is greater than 1. And it is going upward. It is increasing. And asymptote is always going to be the line it is trying to cross on the horizontal axis, but it will never be a 0. So x-axis. So this way you will have the graphs for the others and fill in these boxes.